okay? So these are what our solutions will look like. So what we're going to do today is we're just going to focus on solving based off of graphing, which is a very easy way to graph whenever it works out nice and perfectly, okay? So we're going to look at number 1. So before we do that, though, we're going to take a second. We're going to recall standard form. So when we have standard form, it is y is equal to ax squared plus bx plus c. And we will need our axis of symmetry, which is x is equal to negative b divided by 2 times a. So that is what we will need. Now, the good thing about these is I'm no longer grading every single part of your graphs, right? Last unit was literally just graphing quadratics. I was grading the ins and outs of everything you were graphing. I was making sure every little piece of it was perfect, everything was good, that you could do all of the things on the graph and understand where everything's at, understand what it is, all of the things. On this, I'm not as concerned about all the little pieces. I'm more concerned about you graphing it right, but getting the solution, okay? So I'm not looking for all the tiny little details anymore whenever we solve by graphing, okay? So when we look at this, we're going to go ahead and start with number 1. What is our A term here? 1. What is our B?
4.
What is our C? So we're going to use those, and we're going to find our axis of symmetry. So we're going to do x is equal to negative b over 2a. What do I need to plug into the numerator?
4.
What do I need to plug into the denominator? So the numerator gives us negative 4 divided by 2 times 1, which is, or 2. What is negative 4 divided by 2? Negative 2. Okay. So our axis of symmetry is what we put in the very middle of our table. We can use our calculator to calculate everything else. Now, for graphing this part, whenever we graph it, if you do not include your axis of symmetry for this one, that's okay. I like to include it just because I've found that it makes my graphing go a little bit faster, just because I can use the fact that it's symmetric and not have to count everything out and just go, oh, it's a point here. Oh, so that means there's going to be one here. But we are going to have to fill in our table. The table has to be completely filled in. What is something that's 1 smaller than negative 2? Smaller than that? Smaller than that? Bigger than negative 2? Bigger than that?
0.
Bigger than that?
1.
Okay. You will notice the table is a little bit bigger. Okay, that is done on purpose to ensure we get to see the full picture and we get the list of our points that include our solutions. So use your calculators and put that in. Has anybody done that already? What is the y value when x is negative 5?
Can we not plug it into your x? Your x into your...
Can we not plug these into here?
No, like, you know you got negative 2. Can you not put them in as the x and plug your y?
Mm-hmm. But we can do that, yeah. But I'm also okay if we just fill in the table using the calculator to do that. This is me being less particular for graphing this unit because it's such a tiny portion of it and it's not the main goal. The main goal is to find our solutions. So what is our y value when x is negative 5?
0.
What is our y value when x is negative 4? When x is negative 3? When x is negative 2? When x is negative 1? When x is negative 5? Or when x is 0? When x is 1? Okay, so that gives us all of our points, and we're going to graph them. So we have negative 5, 0, negative 4, negative 5, negative 3, negative 8, negative 2, negative 9, and then we're going to plot the rest of them. And we are good to draw in our graph. Now, how many times does our parabola touch the x-axis here? 2 times. Where does it touch the x-axis at? What x values?
Negative 5.
at -5 and +1. So we can find our solutions by seeing where our y equals 0 or where it crosses the x-axis. So to write our solution for this, we do x is equal to, and we're going to write it in something called set notation, which is where we use a squiggly bracket to write out the list. So well, x is equal to, and we go from smallest to biggest. What's the smallest x-intercept? Comma, what's the biggest x-intercept? So our solution is x is equal to -5 to 1. Okay, -5 and 1. That's not an interval, it's not a point, it's just listing out your solutions to x. Okay, you don't have to list the y coordinate in the solution because what is the y coordinate for both of those? 0. Because that, when you say it's the solution to the quadratic, you know that that means the y is 0. That's automatically decided. So we can write it out as just a set of the numbers x can equal. All right, now let's look at number 2.
Wait, is it 2?
It is 2 solutions, yep. Okay, we have both of those, so we have 2 solutions. All right, now we're gonna look at number 2. So for number 2, what is our A term?
1.
What is our B term? What is our C term? So from here, we're going to find our axis of symmetry. So we have x is equal to -b over 2a. What do I need to plug into the numerator?
-2.
What do I plug into the denominator?
1. This is equal to 1.
Because a negative and a negative in the numerator make that +2 divided by 2, which is 1. And that's what goes in the center of our table. What is 1 point less than 1? 1 less than that?
-1.
Less than that?
-2.
1 bigger than 1? Bigger than that?
3.
Bigger than that?
4.
There we go. So I want y'all to use y'all's calculators and fill in that table for me. When we plug this in, what is our y value when x is -2? When x is -1? When x is 0? When x is 1? When x is 2? When x is 3? When x is 4? None. Okay, and then we're good to graph that. So if I want to put our axis of symmetry on there, we can. And then plot our points, -2, 9. That would also have a point over here that's symmetric, -1, 4. Has a point on the other side that's symmetric, 0, 1, 1, 0. How many times does this graph cross the x-axis? 1 time, right? Okay, and it is only where the vertex is at. That is the only time it touches the x-axis. Okay, we can also see it because it only equals, our y equals 0 1 time. So for our solution, we still write it the exact same way, but how many things are going to go inside of there? Just 1. Okay, and that is our solution. That is one solution. That's what it looks like when we have one solution. Just the vertex is touching the x-axis. Okay, and we're going to look at number 3 together as well. For number 3, what is our A term for number 3? -1. What is our B term? And our C? -3. Okay, so if we set this up, we have x is equal to -b over 2 times a. What do I need to plug into the numerator? What do I plug into the denominator? So this is going to give us -2 divided by -2, which is equal to +1. And that's what goes in the middle of our table. What is 1 smaller than 1? What's smaller than 0? Then,
-2,
okay, bigger than 1.
2,
Then,
3, 4.
so we use our calculator, fill that in. So when x is -2, what is our y value? -11. When x is -1, what's y?
-6,
When x is 0,
-3,
x is 1,
-2,
x is 2.
3,
When x is 3,
-6,
when x is 4.
-11.
All right, so can I fit the points that go to -11 on that graph? No, but is it okay if I don't put one that, just 1 point? That's okay. So we can graph this though. So when we look at the graph, we can't do -2, 11, but I can do -1, -6, 0, -3, 1, -2. Plot the symmetric ones. Now, this is our graph. Does our graph ever touch the x-axis? No. So do we have any real solutions?
No.
So the answer here is no real solution. And I want y'all to do number 4. And yes, number 4 and number 5 are the exact same problem. That's my bad. But do number 4 for me. How many solutions does number 4 have? 2. Okay, what are the 2 solutions? 2 and 8. Okay, so you would write your answer as x is equal to, use that curly bracket, 2, 8. And when you write the solution, you write it from biggest or smallest to biggest, number-wise. All right, so that is all you have to do to solve by graphing, okay? So we're going to do 4 practice problems that we're going to turn in today. So I'm going to go ahead and pass those out real quick. Okay, on your practice sheet, you will notice that it does not give you the table already. You just have to draw it in, okay? The graph is also zoomed in specifically to the area of the graph you need, okay? Okay, so we're going to work on these 4 questions. Then, once y'all get started on this, and I put up the solution so y'all can check those, we are gonna, if you want to go over, if you want to look at your test, I'll let you do that. Yes, this is turn in at the end of class. this is getting turned in at the end of class. Right, I want it turned in before we leave.
No. What? You're like, why should